Maybe it'd be better if I turned on this other light again. Oh. Maybe. Turn on this fan. Man, those things are dusty. Okay, well. This is so crazy having two streams going. One's kind of low quality and the other's not too bad. I don't know how to get this one to be higher quality though. Oh well. Well, let's get started. Let's get started. Physiology and histology. So we talked about the peripheral nervous system. Well, didn't. We did in class, but I wasn't able to go over it in the video or in the stream because I didn't have access to the lecture. But I've got it now, but I don't know if I really want to go over it. I mean, I guess I can. I don't know anything about it. Yeah, whatever. I guess I will. There's a lot of slides though. I'll try and go quick. So, the peripheral nervous system. There's 3 types of neurons. There's other components, interaction between organ systems, non-neural glial cells. Yeah, plenty of textbooks that you can learn about this from. Oh man, I always have upper respiratory problems in the morning for some reason. Anyway. Okay. Okay, there's 12 pairs of cranial nerves, 31 to 44 pairs of spinal nerves. I guess it just varies. These are, the cranial nerves are things like olfactory, optic, oculomotor, trochlear nerves. Yeah, stuff like that. Basically, the peripheral nervous system handles transmission of signals between the central nervous system and target organs like muscles, organs, glands, stimuli. And there's the neurons are the things that carry these things out. Then there's axons, myelinated, non-myelinated. Yeah. Afferent is to the central nervous system and efferent is away. Sensory, afferent, motor, efferent. It's easy to remember if you think efferent, exit, right? Starts with an E. Okay, and then we have somatic and then visceral. Somatic is the external aspect of the body. Visceral is the internal aspect. And then there's autonomic, which is between the CNS and internal organs. Nerve fibers have their own Nerve fibers have their own histology. There's unipolar, bipolar, pseudo-unipolar, and multipolar neurons. Multipolar are the most common type of neuron. Looks like. Yeah, there's an axon, there's a dendrite, there's a soma, a nucleus, axon terminal. Then there's ganglions, which are terminals for um, nerves, I think. We've seen a couple of these in our cadavers, which is pretty cool. Um, they're basically just like bundles of nerves that go different ways, or that branch off to different paths. Yeah. Yeah, sensory afferent, motor efferent, and autonomic. Then you have the five senses. Those are involved with the sensory neurons, right? Temperature, pain, pressure, light, and then certain chemicals. Usually your skeletal, cardiac, and smooth muscles and glands and internal organs are the targets of the motor efferent neurons. And then we've got the autonomic neuronal system, parasympathetic. Hey, Maddox. Parasympathetic is rest and rejuvenate. Sympathetic is flight or fight. May have heard that before. See you later, Maddox. Myelinated versus non-myelinated axons. And then there's something called nodes of Ranvier, I think. I think that's how you say it. Very, very interesting, I guess. Lower motor neuron system. All right, Milo. See you later. Thanks for tuning in. Bye. So basically there's the peripheral nervous system, and then branches of that are the somatic and the autonomic nervous system. And then branches of the autonomic nervous system are the sympathetic and the parasympathetic nervous system. Okay, then there's something called Schwann cells, which make and maintain myelin for the peripheral nervous system. And then one Schwann cell is responsible for a section of myelin on only one axon. And so that's, you've got to have enough Schwann cells for every axon. Okay, Milo, it's good to have you back. Thank you for subscribing. All right, satellite cells. Then there's peripheral nerve endings. Sensory nerves have dendrites and free endings. They also have specialized nerve endings. And then there's something called myofiber neural innervation. Myofiber neural innervation, found at neuromuscular junctions. And the more motor units that are engaged, the greater the strength of contraction. Basically, they have they send acetylcholine to the receptors of the muscle, which causes it to contract. Okay, moving on to the central nervous system. We talked about this yesterday in class. Again, there's a lot of textbooks. There's the meninges, the cerebrum, the cerebellum, and the brainstem, part of the part of the central nervous system. The meninges are a protective sheath for the brain, spinal cord, etc. Hey Milo, what is this? Huh, okay, this just popped up on my phone there. You guys can answer that if you'd like. The meninges also function for CSF circulation. I don't know what CSF is. I've been trying to figure that out since yesterday. Some sort of fluid. Cerebrospinal fluid, probably. That would make sense. Okay, and then there's blood vessel support. That's what meninges do as well. The meninges have the dura mater, the subdural space, the arachnoid mater, the subarachnoid space, the pia mater, the subpial layer, and then they have the leptomeninges, which is the pia mater and the arachnoid mater. Okay, and then we have, yeah, go ahead and do that. Yeah, cerebrum, cerebellum. The cerebrum controls and monitors all cognitive and motor functions, while the cerebellum monitors proprioception and motor learning. The sulci of the brain are the depressions in the brain, like the little grooves. And then the gyri, or gyri, however you say that, are the mountaintops. You know, you've got the groove, and then you've got the, you know, the hill, the wrinkles in the brain. There's gray and white matter in the brain. There's neurons, astrocytes, oligodendrocytes, and microglia in the brain. Gray matter is the neuronal cell body and dendrites, while white matter is the neuronal axons and neuropil. I don't know how you say that. Okay, the cerebral cortex is a part of the brain. And then there's the subcortical white matter. Then there's the basal ganglia, which the basal ganglia is basically just a cluster of neurons. Or no, the caudate nucleus of the basal ganglia. I mean, you've got to keep in mind, these are all very, very complex. They've got plenty of parts each. So that's just great. But anyway, the caudate nucleus of the basal ganglia is a cluster of neurons. And yeah, some parts of the brain are gray and white. Some are one or the other. Then there's the midbrain, which is also called the mesencephalon. Then there's the hippocampus. Then there's the cerebellum. Then there's the brainstem, which is also called the medulla oblongata. Basically, the hippocampus is a part of the cerebrum, and many parts of the brain have many functions. Taking a part out could affect the function of the organism. And also the brain has white and gray matter. Those are the 3 points that I took from all these slides so far. Okay, brain physiology. There's signal transmission via action potentials, otherwise called AP. There's glial cells, astrocytes, oligodendrocytes, and microglia cells. You do, Milo? Okay, that's pretty cool. And then there's ependymal cells. Those are other cell types. What kind of content do you make, Milo? And they all have unique appearances on histology. Okay, neurons. The cytoplasm of neurons contains Nissl substance, and then action potentials are generated at the axon hillock. Sport and gaming. Okay, that's pretty cool. So think of a hand. The hand is the axon, and the fingers are the dendrites of the neuron. Okay, glial or glia cells, I think. You could also say glial cells. Again, these are astrocytes, oligodendroglia, and microglia. The neuropil, however you say that, is eosinophilic fibrillar material between, or fibrillar, I think that's how you say. Hey, Alabama fan, how you doing? The neuropil is eosinophilic fibrillar, I think that's how you say that, fibrillar material between cell nuclei composed of the cell processes of neurons and glia. Not sure what all that means, but I'll probably learn eventually. But it's important because the brain needs oxygen. The brain can't use glycolysis. And so there's plenty of capillaries and microcirculation in the brain. What did my ears just hear? I don't know. A good-looking white man. That's crazy. What about all the non-white men? Nah, I'm kidding. Well, I'm not kidding. They're men too, but thank you. I appreciate the compliment. I don't know if I'm completely white. I might have some Native American in me. I might have some Czech in me. I think Czech is still white, but I don't know. Anyway, the brain needs oxygen, cannot use glycolysis. Thank you, Milo. I appreciate that. And so it's got a lot of capillaries flowing through it so that blood can readily get to it. Astrocytes are important in the blood-brain barrier. They kind of just maintain the brain. The blood-brain barrier has unique capillaries. What it does is it regulates the movement of substances into the brain, and small drug molecules like lipid-based diffusion or carrier molecules can pass through. Hey Russell, yes, I am studying to be a veterinarian. I'm already in vet school. I'm in my first semester. Just a couple months left until break. It's pretty intense, but it's not horrible. Other vet schools have it worse. Well, not worse, just more intense. But yeah, that's the whole purpose I'm here. Okay. Oligodendroglia make and maintain myelin for the CNS, and one cell provides myelin for many axons. Sorry, the top of my soft palate is itchy for some reason. It's always so hard to scratch because you can't really scratch it. Anyway, that's kind of weird. Microglia has resident phagocytes, which are analogous to pulmonary alveolar macrophages in the lung. They're macrophages, but just for the brain instead. So microglia are basically macrophages for the brain. Okay, that's cool, Russell. I'll try to answer them as best as I can. Once I'm a vet, maybe I'll know a little bit more even. That'll be in about 4 years, though. Okay, and then there's ependymal cells. These line the ventricles and the central canal of the brain, which the ventricles of the brain are parts of the brain, and then the central canal is the spinal cord. And they also, the ependymal cells produce and circulate cerebral spinal fluid. Okay, and then, all right, Milo, it was good to have you. See you later. Thank you, Russell. I'll do it. I'll stick with it. Basically, the cerebrospinal fluid is a clear, colorless fluid. It contains glucose, chloride, sodium, magnesium, and then some potassium, calcium, and protein. It protects, supports, and nourishes the central nervous system. Cerebral spinal fluid is produced by modified ependymal cells that outline the choroid plexus to the lateral ventricle, to the third ventricle, to the fourth ventricle, to the subarachnoid space. Interesting. A drippy 6'7" king. What a name. How you doing, man? So 3 things I wrote down at this point were microglia are the brain's macrophages. The blood-brain barrier regulates stuff entering into the brain. And then I said the CSF is some kind of fluid in the brain, because at this point I was just kind of done in the lecture and I was just pooped. But yeah. Okay, so the spinal cord. Hair a bit rough, skin a bit tan, lips thick. Bro, come on. My hair's a bit rough. Nah, I'm kidding. You're probably right. But why are you rating my appearance right now? That's crazy. Again, we have gray matter, we have white matter. The white matter has sensory and motor components, it looks like. Sensory is ascending and motor is descending. Again, you gotta remember the sensory stuff is coming from the muscle to the brain, and the motor stuff is going from the brain to the muscle to tell it to do, if your hand's on a hot stove, you've got sensory stuff going to your brain, and then you've got motor stuff going to your hand to tell it to move your hand. It happens very quick. That's why you move your hand so quick. But you can still get burnt. But anyway, that's it for physiology and histology. Hey, desktop stream, how you guys doing? I wish I could see comments, but I cannot. I don't know where they went. Okay, well, maybe they'll appear some other day. Okay, next we have epidemiology. So in epidemiology, it was very interesting. We talked about, well, I can just pull it up here, kind of. We talked about the scientific method. We talked a little bit more about it. There's p-values, right? So science can't prove anything. It's always just trying to find the best explanation, a suggestion. You can't ever really prove anything with science. You can just find a really good reason, and it's more of a suggestion, really. Like, oh, maybe this is how it works. Yeah, it could be how it works. Could be a fact, but it's not guaranteed. Okay. So there's something called a null hypothesis, and that assumes no association. So, if, for example, I'm saying uh, all red cows do produce milk. That's my claim. Then the null hypothesis would be no red cows produce milk. Or not all red cows produce milk. Something like that. Hey, Alexander. Greetings from Venezuela. That's awesome. It's good to have you. Thanks for joining us here. Okay. A fourth year vet. Yeah, that's an example. Okay, well, this is a good example. So if a vet student were like, man, they're only calling me in for these emergency cases, I think they've got a vendetta against me. I think they just want me out of here. They're trying to prevent me from graduating. Well, the appropriate null hypothesis for her query would be there has been no significant difference in emergency calls between all students on the rotation. Everyone's being called the same amount. Yep, it's a good day so far, Alexander. Well, I mean, every day's a good day, whether I have a good day or not, because this is the day the Lord has made, and I'm going to rejoice and be glad in it. But something important is there's type 1 errors and there's type 2 errors in the scientific method. I don't fully understand this part yet, but it's something I'll probably come back to. Samples are never a perfect representation of the population. Some difference will always be found. I mean, if you want a perfect representation of the population, you need to study every single constituent of the population. That's the best study, but it's unrealistic. It takes a lot of money probably, and it takes a lot of time. And so is it ever going to happen? Very unlikely. But yeah, I mean, it could. It would just, that's why people do samples, is because it's cheaper, still somewhat reliable compared to a complete study. Why does my dog eat dirt? Is that normal? Could be. How much dirt? For example, if you've got two averages, just because they're further apart, if there's any overlap, he stuffs his face in it. It's weird. Well, I'm not a doctor. I'm just a vet school student. But if I were to guess, it could just be that he's sniffing for some critter. If he's stuffing his face in it, there's probably something down there making noise or something that he smells. That's just kind of normal dog behavior. They do goofy stuff like that. They eat grass. Sometimes they eat grass because their stomach hurts and they're trying to throw up. So, well, that's pretty much the only time they eat grass. They're not really herbivores. They're pretty much carnivores, actually. Now, technically, they're, I would say, facultative carnivores, which is equivocal to an omnivore, but it's leaning more toward carnivore because their digestive tract is very optimized for eating animal products and not so much optimized for eating plants. They could live and thrive off animal products, for example, but they could not do the same for plants. Can dogs be autistic? Yeah, probably. I can't guarantee it, but I imagine so. They've got very similar brains to what we have. But yeah, it's important epidemiology and just evidence in general is important because you're welcome, Rise and Fire. Not a doctor yet, but I will be in about 4 years. I appreciate you, and you're welcome. Happy to help out as much as I can. But yeah, I wouldn't worry about the dirt. It's just dogs probably do that. But if it becomes a problem, like if he starts getting a rash or something, then I would take your dog to the vet if that's something that concerns you. The 5 most important things to understand about your pet. If your pet stops doing any of these things, eating, drinking, pooping, peeing, or breathing, then you might want to take your pet to a doctor, right? Especially if your pet stops breathing. But all those other things, they're also very important, because if your pet stops eating, it's going to die. If your pet stops drinking, it's going to die. If your pet stops pooping, it's going to die. If your pet stops peeing, it's going to die. And if your pet stops breathing, it's going to die. So, you might want to take it to a doctor if any of those things happen. Okay, then we had a library orientation, and then we had, yeah, okay. Well, y'all, that's all I got for today. Thank you all for tuning in to my stream. And, yeah. Appreciate y'all. And thanks for watching. I'll see you in the next one, hopefully tomorrow morning, same time, or around the same time, 4 to 8 a.m., very likely. And, yeah, thanks for watching. See y'all later. And